ready to talk about section 1.8, linear and absolute value inequalities. The first concept that we need to discuss in this section is the topic of interval notation. Interval notation takes some getting used to if you've never seen it before. So we're going to do a few examples, just kind of getting used to what interval notation means and making sure we're comfortable with how it looks. Let's start with, I've got a couple of number lines drawn up here. I want to express an inequality like x is less than 4 in interval notation. So let's write, I want to write x, let's do x is less than 1. I want to write x less than 1 using interval notation. In order to do this, I need to graph it. Let's see what it looks like on the graph. If I graph x less than 1, I'm going to locate the 1. All right, you probably think about, I know you've done these before, so you have to remember, sometimes you used an open circle, sometimes you used a closed circle. If this is just strictly less than and it does not have equals with it, you're going to use the open circle. So we're going to find the 1, we're going to draw an open circle, and we want everything less than 1, so everything smaller. We want to graph everything to the left, back this way. So we're graphing x less than 1. Okay. In this class, I will tend to use a different symbol in place of the open circle. I will be using these round parentheses to mean the exact same thing. So that's the same graph of x less than 1, but I'm just using the round parentheses symbol in place of the open circle. Once I have this graphed, I'm ready to give the interval notation. The interval notation is like it's almost like, you can think of it as a shorthand way to write what you just graphed. So we're going to read our graph from the left side to the right side, and we need to say where the graph begins and where the graph ends. So for interval notation, we're going to say that the graph is beginning over here at negative infinity. It's going forever in this direction into the negative values. So it starts at parentheses negative infinity, and then it continues going left to right until it gets to 1, and then it stops at 1. 1 is not included, so we can indicate that 1 is not included with the round parentheses symbol. So that would be my interval notation. Parentheses negative infinity, comma 1, parentheses describes the graph that I've just done here. Okay? Let's do another one. This time we want to, let's say I want to graph x greater than or equal to negative 2, and then I want to give my answer in interval notation as well. Okay? So let's locate, how do you graph x greater than or equal to negative 2? Here's negative 2 on the graph. All right, you probably would use a closed circle at negative 2. Well, I shouldn't say probably. You would use a closed circle at negative 2. Why do I use the closed circle? Well, because this time this says that x is greater than or equal to. So the closed circle tells me to include the negative 2 as part of my solution set. So starting from negative 2, now I graph everything larger than negative 2. So I'm going to shape everything to the right from negative 2 on my graph. Okay. In this course, we will be using another symbol that means the same thing as the closed circle. We're going to use a square bracket. So we can draw a square bracket like this, and then shade everything to the right. Okay? So the square bracket replaces the closed circle. The round parentheses symbols replace the open circles. And try not to get confused using those new symbols. You'll notice that try not to worry about which way to have your symbols, what direction to have your symbols in, because if you notice, the symbol is always going to enclose or just kind of surround the area that's been graphed. So if you graphed everything on the left side, then you're going to use the symbol that kind of points to the left side. And over here, we've graphed everything this way, so we would use the square bracket that kind of points to the right side, like that. So that's how we decide which way to point the brackets and the parentheses. You don't have to use the brackets and the parentheses, you can still use the circles, but the brackets and parentheses are used in interval notation, so it's good practice to go ahead and use it on the number line as well. All right, so now that we've got a graph to look at, how would we write this same value using interval notation? We need to express this graph in interval notation. So again, we read our graph from left to right. If you start over here on the left side, where does the graph begin? It begins when x is -2. And we include the -2 indicated with a square bracket. So we're going to say square bracket, -2, comma. How far does the graph continue? Well, it continues all the way out to positive infinity. And this is the infinity symbol, like a sideways 8. And then infinity always has the round parentheses with it. So my interval notation is square bracket, -2, comma, positive infinity. And I hope you can see, can you see that? Yep, you can see that. Okay, good. All right, so let's just kind of recap. There's a lot of new symbols and a lot of new terminology here. First of all, the infinity symbol looks like a sideways 8. It just simply means that you're going out positive direction forever. This is the negative infinity symbol. It just has a negative sign in front of it, and it tells you that you're just way out here to the left forever. You use a closed circle or a square bracket. Closed circle or square bracket, or this, just depending on which way your graph is going, to indicate. You use this if you've got x is equal to, so like if you've got x less than or equal to, x greater than or equal to, you're going to use the closed circle or the square brackets. If you have x less than or x greater than with no equal signs, then you can use the open circle, and you would use one of those parentheses depending on which way your graph is going. Just checking to see if you can see that. Okay. All right, let's look at some more examples. This does take some practice. Let's look at the example in the notes. Example 1. Example 1 asks us to write an inequality whose solution set is the given interval. Okay, so for part A, we have interval parentheses, -infinity, comma, -9, parentheses. Okay, so let's start by graphing this. Okay, now I'm not going to put every number from -9 to +9 up here. That's not necessary. Here's -9. I'll put some numbers surrounding it. Okay, how do we read this interval? This is -infinity to -9. And it I'll ask you, does this include the -9? No, it does not, because it's got the round parentheses. That's like having the open circle. So we want to shade everything from -infinity to -9 on the number line. When we come to -9, you can use either the open circle or you can use the round parentheses. I'm going to do it both ways because I think it's helpful to see it both ways. All right. Now that I've got it graphed, I can give the inequality. I'm being asked to. This said write an inequality, so that means you're going to write it in terms of x. So if you think of this in terms of x, how can you describe this? We've shaded everything less than -9, so we need to say that x is less than -9, because x corresponds with the areas that have been shaded. X is the answer, and the shaded area is our answer. So x is less than -9. So this is the inequality. That means the same as interval notation, -infinity to -9. Let's look at part B. We have square bracket 0, comma, infinity. Okay, so I'm just going to put, I'm not going to put a large number line, that's not necessary. All right, I just need this number and a few numbers around it, and that's enough. I need to shade everything from 0 to positive infinity. Again, integral notation is always read from the left to the right, just like the number line is read from the left to the right. So go to the 0. If you're thinking in terms of circles, decide what type of circle you would need. This is a square bracket, so that means that 0 is included. So you can do this closed circle at 0, shade everything larger because it goes to all the way to positive infinity. So go this way, and then you can do, or you could say square bracket, graph everything to positive infinity that way. And then we want to write it as an inequality involving x. So if we think of this in terms of x, we have started at 0 and we went out forever, so we want everything that is greater than or equal to 0. So our inequality would be x greater than or equal to 0. So that's the inequality for the integral notation that we see up here. For example 2, we are asked to solve the linear inequality and then write the answer in integral notation. How is this different from what we were doing already? Well, we're just building on it a little bit. Solving a linear inequality is very much like solving just a regular linear equation. You do have to be a little bit careful. For example, let's talk about how you would handle this if instead of the less than symbol, what if you had an equal sign? If you had an equal sign, you know that you would do negative 3x minus 9 equals 0. You would add 9 to both sides. You would solve negative 3x equals 9. You would divide both sides by negative 3. And you would have x equals negative 3 for your answer. Okay? Well, we do this very much the same way, but with it being an inequality, we have a lot more answers than just negative 3. We're going to have everything either larger or smaller than negative 3 for our answer. So we have an infinite number of solutions here. Another thing that you have to be super careful about, this is in your notes, but make sure that you remember this. If you recall from working with linear inequalities in the past, anytime that you multiply or divide both sides of an inequality by a negative number, you have to be careful that you remember to flip the inequality symbol. I'll take a moment and explain why that happens. For example, let's say you've got 2 is less than 5. Okay? We know that's a true statement. What if I multiply both sides of this by negative 1? If I multiply both sides of this by negative 1, that becomes negative 2, negative 5. Negative 2 less than negative 5 is a false statement. So as you can see, multiplying or dividing both sides of an inequality changes the original truth value, or excuse me, it changes the truth value of your original statement. So in order to maintain the truth of your equation, or your inequality rather, make sure that you remember to flip the inequality symbol anytime that you multiply or divide by a negative number. So make sure you remember to do that. Do whatever it takes to make sure you don't forget. And now let's take a look at how to handle part A. So I'm going to start by adding 9 to both sides. And then I'm going to divide both sides by negative 3. Let's see, I'm going to write an extra symbol. So negative 3x divided by negative 3. And because we are dividing by a negative, we need to flip the symbol to a greater than symbol. So divide both sides by negative 3 and flip your inequality. That gives you x is greater than negative 3. So this is the inequality version of the answer involving x. We're asked to give the answer also in integral notation. Look at the graph first. So I've got negative 3, it's going to go right in the center, and then I need some numbers on each side of negative 3. Okay. I need to graph x greater than negative 3, so you can do the open circle, but I'm going to go ahead and use the round parentheses now. Shade everything to the right side. Okay. Now that I've got it on the graph, the integral notation is like just a shorthand way of writing the graph. The integral notation begins, well, the graph begins at negative 3. So in integral notation, I need to write parentheses, negative 3, comma, And then how far does it go? It goes to positive infinity. So put the infinity, and infinity always has the round parentheses symbol with it. It never has a square bracket with infinity. So that's your interval notation. Parentheses, -3, comma, infinity, parentheses. Example 2, part B, we have the same directions. We have to solve and write in interval notation. You're probably noticing that you've got fractions this time, and most people don't like having to deal with fractions, and that's okay. Just like you could do when you were working with equations, if you recall, if you're working with equations that involve fractions, you have the privilege, I guess you could say, of eliminating those fractions if you just multiply both sides of the equation by the LCD. You can do the same thing here as well. What is your LCD? Take a moment, think about that. Pause if you need to. Okay, so you look at all of your denominators. You've got a 2, that's a 1, that denominator is a 4, and that denominator is a 1. So looking at all of these denominators, you want the least common multiple of 2, 1, and 4. The least common multiple is going to be 4. That's the smallest number that each of these denominators can evenly divide into with no remainder. Okay, so my LCD is 4. So I want to multiply each term. I want to multiply both sides of my inequality by my LCD, and of course I have to distribute. So you can think of this as multiplying each term by your LCD. So we're going to do 4 times 1/2 x minus 3 times 4 greater than or equal to 4 times 1/4 x plus 4 times 2, or 2 times 4, either way. And simplifying this will eliminate the fractions. 4 times 1/2 x is going to be 2x minus 12 is greater than or equal. 4 times 1/4 x is just going to be 1x plus 8. All right, I'm going to ask you to pause here and continue with the problem and see how far you can get with it, and we'll check when you come back. Okay, so let's see how you did. First, you do not have to do the same you do not have to do your steps in the same order that I'm doing mine in. We'll talk about different ways that your answer might look at the end. But because this is an inequality, I personally find it helpful for my x to essentially land on the left side of the problem. If you've got x is less than a number for your answer, or you've got x is greater than a number for your answer, that's a lot easier to visualize on the graph than if you get something like 6 is greater than x. So whenever you're working with inequalities, it's going to be helpful if you try to get your x to end up on the left side of the inequality in the final answer. So in order to accomplish that, I'm going to subtract x on both sides. And that gives me x minus 12 is greater than or equal to 8. And now I want to add 12 to both sides. So x is greater than or equal to 20. Okay, so x is greater than or equal to 20. Before I give my answer in interval notation, I would like to see how it looks on a graph. Again, I'm not going to put a lot of numbers on here. I'm going to put the number that I need and just a few on each side. Okay, I need to graph everything greater than or equal to 20 on my number line. So I'm going to locate 20. I noticed that 20 is included, so you could use a closed circle, and I don't know if you can see that. Let me see if you can see that. You could use a closed circle to indicate that 20 is part of the solution. I'm going to use the square bracket. And I'm going to shade everything larger than 20, everything greater than. So I'm going to have a square bracket at 20 and shade everything to the right. And it's very important that if you're doing a problem, if you're doing a graph on a test in the classroom on paper for me to check, make sure that I can see where your graph is. Sometimes it's not clear where the students draw their graphs. Sometimes the whole thing might be like the same shade and I can't really tell where it's graphed. So just make sure I can see where your graph is supposed to be. So this is the graph, and now to give the answer in interval notation, I'm just going to say that, well, my graph starts at 20, and I've got the square bracket at 20, so my interval notation needs to start with square bracket 20. So square bracket 20, comma. How far does my graph go? It goes out to positive infinity, and I know that I always put round parentheses with infinity symbols. So this is my interval notation. Square bracket 20, comma, positive infinity.